Okay, so as a follow-up to the last video, we're now going to apply some of the parallel line theorems to proofs. And so we'll take a look at a couple of proofs here. I probably won't write out the entire proofs. One thing you might want to do is have the theorems out from the last worksheet. And I think it's on the second page of the last worksheet. Okay, so let's take a look at this first proof here. It's given that PVS is congruent to PWU. Hopefully you can see that those are alternate interior angles, which tells you that the top and bottom lines are parallel to each other. Not sure if we need that. ST is congruent to RU, and I know that VT is congruent to RW, which by subtraction I know that these two are congruent to each other. And I can see that it looks to me like I have a couple of triangles here that are going to be congruent to each other, right? I see that this is going to be congruent to this because I have this angle congruent to this angle because they're vertical angles. So I can see that those two triangles are congruent to each other. I also have that this entire angle is congruent to this entire angle right there. That's another given. And what we're trying to prove here is we are trying to prove that these are parallel lines. And so RS is parallel to TU. That's what we're looking for. And if I'm working backwards on this, I can hopefully you can see that what I really need is this angle to be congruent to this angle, because those would be alternate interior angles. So I'd be looking at this, this, and that to get the lines parallel to each other. And it looks like I should be able to get a CP/CTC from this being congruent to this, and then do a subtraction to get those alternate interior angles congruent. So let's take a look at this and just kind of do a quick outline of what we would need to do here. I know that I have triangle SVP congruent to triangle W, sorry, it would be triangle UWP. It's going to be by angle side. And then I can do a CP/CTC to get angle VSP congruent to angle PV, angle WP, WUP. Yep, sorry, this angle right here congruent to this angle right there. Oh, sorry, no, this one congruent to this one. And then I can get angle RSU congruent to angle TSU by TUS by subtraction. And now that I have that congruent by subtraction, I know that I have parallel lines, so I know that these are parallel by, and make sure you get it in the right order, it's going to be because of the alternate interior angles being congruent, then I can conclude that I have parallel lines. Okay, so that's the direction I'm going to need to write that reason. Okay, so let's flip over to the back side of page 1 here, and let's take a look at another proof. Okay, we're on the back side here of page 1, and we're looking at another proof. I know this one's a pretty tough proof, so let's take a look at it. I know that I'm given these parallel lines. I know that AD is parallel to BC. And I know that E is the midpoint of DB, so I know that this is congruent to this. And because of the parallel lines, I got a bunch of congruent angles, like this angle is congruent to this one, alternate interior angles. I know that this one is congruent to this one, and there are also alternate interior angles. I also have vertical angles here and here. So that'll tell me that I have congruent triangles there, but ultimately I'm trying to prove that EFB, that this angle right here is congruent to this angle right here. And hopefully you can see that those are alternate interior angles too. So really what I want to do is try to get this side parallel to this side. Okay, so let's see if we can't get ourselves there. And so I know that I can prove the triangle is congruent by angle, angle, side. So triangle AED is congruent to triangle CAB by angle, angle, side. Okay, and then I gotta try to figure out, okay, what angles will help me get that those two sides, AB and DC, are parallel to each other. And what I have here is I have a situation where I can say that it looks like I can prove a different set of triangles. So I can prove this side parallel to this side, or sorry, congruent to this side by CP/CTC. So let's do an AD congruent to BC, and I got a reflexive property right there. So that means that AC is congruent to itself right there, which will tell me that these two triangles right here are congruent to each other. So like this one and this one are going to be congruent to each other. Hopefully you can see that. And so I have triangle, get the color back, triangle ACD congruent to triangle CAB. Okay, and that would be by side angle side. Side angle side. This is going to be a CTC. Okay, and now that I have the side angle side there, it looks like I can do a number of things, but I definitely can do this congruent to this. So angle BAC is congruent to angle DCA using CP/CTC. And now I can say that because those are going to be alternate interior angles, right? So I got alternate interior angles right here, which then tells me that AB is parallel to DC. Because if I have alternate interior angles congruent, then I have parallel lines. And then now that I have the parallel lines, now I can go ahead and say that these are congruent, because if I have parallel lines, now the alternate interior angles are congruent to each other. Okay, that's a tough proof. It's a detour proof mixed in with some parallel line theorems. So if you understood what we did there, the other proofs shouldn't be too bad. I know I have 3 more proofs for practice on the next page. I'm going to let you go ahead and use that just for practice. Okay? All right, good luck.